December 1944. Picture a hangar on the fringes of Rechlin, dimly lit, where the air is heavy with the scent of oil, scorched metal, and the quiet despair of a losing war. Germany was still fighting, but every man inside that building already felt the shadow of inevitability. Beneath the harsh glare of a single floodlight sat a massive wooden crate, its stenciled letters fading. Pratt and Whitney aircraft, R-2800. It had been salvaged from the wreckage of an American P-47 Thunderbolt downed over northern France. The fuselage of the fighter lay twisted and blackened, but the heart of the machine, the enormous 18-cylinder engine, had survived intact. Dear friends, if this video has reached you, it's not by chance. Right now, click the subscribe button and the notification bell. Write a number from 1 to 5 in the comments. I will personally respond to the first 50 comments, and make sure to watch the video until the end. Technicians from the Luftwaffe's experimental division circled it like acolytes, approaching a sacred relic. "So this is what powers their flying milk bottles," one muttered, echoing the derisive nickname German pilots had long applied to P-47s. To them, this American fighter was a lumbering behemoth, a machine that flouted every law of graceful engineering. How could it climb so high, endure so much damage, and still make it home? Berlin's orders were unambiguous: dismantle this engine, scrutinize every part, and uncover its secrets. With crowbars, the crate was pried open. The mechanic stepped back as the floodlight struck bare metal, 1,200 pounds of alloy and raw power. The double-row cylinders formed a perfect circle, their surfaces gleaming beneath a thin layer of grime. Otto Henschel, a junior engineer, ran his fingers across the casing, tracing the embossed letters. Double Wasp. He had repaired hundreds of BMW 801s, the lifeblood of Germany's own FW190s, but this engine seemed almost alien. The cooling fins were thick, bolts oversized, the exhaust manifold laid out in a pattern no one recognized. "Too heavy," someone said dismissively. The Americans overbuilt everything. Henschel said nothing. He had heard that before, and he also knew that overbuilt sometimes meant built to endure. A silence settled over the hangar, broken only by the clink of wrenches and the hiss of kerosene lamps. Outside, snow drifted across the airfield, muffling the distant thunder of artillery on the Western Front. Inside, the Germans embarked on the meticulous, almost ritualistic dismantling of a masterpiece they barely comprehended. When the cowling was removed, a sweet metallic scent filled the air. The first cylinder head revealed a precision so immaculate that even senior engineers paused. Threads cut with such finesse that they seemed polished by light itself, surfaces free of tool marks or imperfections. These were not handcrafted parts. They were the product of an industrial civilization operating on a scale Germany could no longer imagine. In that moment, the tone of the hangar shifted. Jokes faded. Laughter ceased. Henschel realized he was looking at more than machinery. He was staring at the very embodiment of American industrial might. Every surface told a story of mass production perfected, of factories running ceaselessly, unconcerned with bombings, with supply lines stretching across oceans. Every engine rolling off the assembly line in Connecticut was a promise. For every one lost, 1,000 more could take its place. When the engine was rotated to reveal its rear, murmurs rippled through the team. A massive turbine housing loomed behind the crankcase, larger than any supercharger they had ever seen. Henschel leaned closer, tracing the labyrinth of stainless steel ducts feeding into the intake manifold. "It's not a simple supercharger," he whispered. "It's a turbocharger, driven by exhaust gas." The chief engineer's frown deepened. "Impossible," he said. Turbocharging demanded heat-resistant alloys Germany simply could not spare. Nickel, chromium, cobalt all rationed, all scarce. Yet here it was, humming in captured glory. The older engineers exchanged uneasy glances. Years had been spent perfecting the BMW 801 and Daimler-Benz 605, tuning them for power and efficiency. But this was raw strength forged through abundance. Not elegant, not clever, but unstoppable. Outside, the wind screamed across frozen runways. Inside, under flickering lamps, a German mechanic stared at a machine that should not have existed and understood a truth few dared to speak aloud. The war had already been decided. Not in the skies by ace pilots, but in factories, where steel was transformed into miracles faster than any empire could comprehend. In the winter of 1944, the Luftwaffe's technical bureau was drowning in grim realities. Squadrons once commanded by seasoned veterans were now led by barely shaven boys. Fuel was so scarce that training flights had dwindled to 30 minutes a week. Yet across Western Europe, a strange new American fighter kept appearing, bigger, heavier, louder than anything the Germans had known. Intelligence officers at Adlershof called it the Thunderbolt. Reports from pilots sounded like exaggeration, even fantasy. We hit it dozens of times, one transmission read, and it kept flying. Another claimed a P-47 had dove through a formation of FW-190s, guns blazing, vanishing into clouds before anyone could react. High Command initially dismissed these stories. No plane that size could fight like that. But wreckage began to arrive. Crashed Thunderbolts were recovered across occupied Europe, and each examination deepened the mystery. Engines enormous, fuselages like armored vaults. A single machine gun burst that would tear through a Messerschmitt barely left a scratch. Luftwaffe pilots who had mocked the flying milk bottle now cursed it. One veteran from Jagdgeschwader 26, the elite Schlager wing, summed it up bitterly. They fly like anvils, and they fall on us the same way. What truly unsettled German engineers was not the Thunderbolt's toughness, but its altitude. On the Eastern Front, the Luftwaffe had ruled with the FW-190 Isabon-IA dogfighter, built for low to medium altitudes. Over Western Europe, P-47s climbed beyond 30,000 feet, far above the operational ceiling of most German interceptors, striking from above with terrifying speed. The secret lay in its engine, the Pratt & Whitney R2800 double Wasp. At altitude, where air thinned and temperatures threatened to freeze metal solid, it maintained full power. The BMW 801, by contrast, gasped above 25,000 feet, its mechanical supercharger struggling to feed the cylinders. And so, in a quiet hangar in Rechlin, under the dim glow of a single lamp, German mechanics confronted a simple truth. Their empire had been outbuilt, outproduced, and outlasted. Imagine for a moment the halls of the Luftwaffe's technical office, a place where pride and desperation collided. The Americans had done something remarkable, something the German engineers could not ignore. Orders crackled across the wires to the Rechlin Test Center. Recover every intact R2800 engine from wreckage, strip it down, and reveal its secrets. The mission was simple in theory. Uncover the mechanism, replicate it, and reclaim parity in the skies. Yet by then, the industrial might of Germany was crumbling beneath relentless Allied bombardment. Factories for ball bearings in Schweinfurt lay in ruins. Aluminum plants in Norway had been shattered, and fuel refineries in Ploiest smoldered under the assault. Even if the Americans' secret could be uncovered, could it truly be duplicated? Pride demanded the attempt. Understanding the Americans required a mirror of German thought and a rare insight into German engineering philosophy. To the minds at Daimler-Benz and BMW, an aircraft engine was not just machinery, it was a masterpiece. Each component was hand-fitted, every bearing scrutinized by the human eye. A craft where precision and beauty were inseparable. These machines sang when materials were pure and hands were steady. Yet, this elegance came at a cost. It was perfection designed for art, not war. Across the Atlantic, philosophy took another shape. The R-2800 was built for mass production, not admiration. Every bolt, every thread, every gasket was standardized, enabling thousands of factories across the United States to churn out identical engines with surgical precision. Machines measured parts to the micron, leaving no room for the individual touch of a craftsman. Where Germany built art, America built quantity, and in the unforgiving arithmetic of war, quantity transformed into quality. By early 1944, the consequences were unmistakable. German pilots labored on two fronts, each sortie demanding hours of meticulous maintenance. American engines, by contrast, flew mission after mission with minimal attention. A single factory in Connecticut could produce more R-2800s in a month than Germany could hope to assemble of its finest engines in a season. For the Luftwaffe, a captured P-47 engine was far more than a curiosity. It was a question of survival. If they could decipher this mechanical leviathan, perhaps they could find a counter. So, when a Thunderbolt fell near Caen, its engine largely intact, it was transported across Europe under heavy guard. The crate that reached Rechlin in December was no mere scrap metal. It was a symbol of everything Germany was losing: altitude, speed, time. A senior engineer reported to the Ministry of Armaments, "We believe the Americans have solved the altitude problem through wasteful use of materials and fuel." He intended it as criticism, yet the truth was harsher. The Americans could afford waste. They had aluminum, fuel, factories, manpower in abundance. The Thunderbolt was no miracle. It was the logical offspring of an economy that dwarfed Germany's. Still, the Germans would not bow without one last defiance. They would study the engine, prove that understanding, if not replication, was still within their grasp. Henschel and his team were chosen for their unmatched expertise in radial engines. When the crate arrived, it was approached not as a trophy, but as a challenge to professional pride. Before the first bolt was turned, the chief engineer addressed the men. "Gentlemen, this engine is not magic. It is metal and mathematics, and both can be conquered." They nodded, unaware that, in the hours to come, their certainty would begin to unravel. Inside the R-2800 lay not merely superior engineering, but a philosophy of war materialized in steel. Reliability over elegance, production over perfection. Picture the hangar silent, but for the steady tick of tools, each turn of a wrench a heartbeat. Otto Henschel crouched beside the massive engine, gloved fingers tracing the bolts. The Americans had built a fortress, every joint sealed, every connection reinforced. When the first layer of metal came free, a hiss of stale oil and burnt residue whispered the ghost of its last flight over France. The engineers leaned closer. Under the harsh floodlights, the engine's anatomy gleamed like sculpture. To a German eye trained on the BMW 801, compact and efficient, this was chaos. Oversized cylinders, thick walls, heavy clamps, redundant systems. "It's absurd," muttered one technician. "They've built it as if weight doesn't matter." He wasn't wrong. The R-2800 weighed nearly a ton, almost twice the BMW 801. Yet Henschel noticed something others hadn't. It wasn't just heavy, it was unbreakable. He removed a cylinder head, studying the valve assembly. Every thread flawless, every gasket fused to metal, every surface machined to perfection. The chief engineer leaned over, examining it under a magnifying glass. No burrs, no imperfections, no trace of tool chatter. It was precision akin to watchmaking, but multiplied thousands of times. "Look at the uniformity," Henschel whispered. Every part could be swapped between engines, and it would still fit. This was revelation number one. German engines were unique, hand-fitted, adjusted by artisans. The American engine was a machine of exacting tolerances, built for interchangeability, for scale, for war. Then came revelation number 2. Behind the rear housing lay a massive circular assembly, unlike anything they had imagined. The chief engineer's brow furrowed. This wasn't the small mechanical compressor they expected. It was a turbine, linked to exhaust ports by a web of polished ducts, a gas-driven turbocharger, reclaiming waste heat to force air into the cylinders. Henschel carefully removed the casing. Inside, a wheel of blades glittered. He touched the metal and recoiled. The alloy was strange, smooth-hard, faintly iridescent. A metallurgist whispered, "This is not steel." It was Inconel and nickel chromium alloy, able to endure temperatures above 700 degrees or without deforming. Germany had experimented with such metals, but never on this scale. The Americans had built entire engines from it. Slowly, the truth sank in. The Thunderbolt's ability to climb to 30,000 feet was not magic. It was metallurgy. Its turbo system maintained sea-level power, even in air, thin as mountain frost. The exhaust piping alone stretched more than 15 feet, circling the engine like veins. The German engineers saw the logic, but the practicality was unthinkable. To build one of these, the chief engineer murmured, "We would need half the resources of the Reich." Even the cooling system revealed ingenuity. Rather than rely solely on airflow, the Americans had created a labyrinth of baffles, oil lines, and intercoolers to distribute heat evenly, crude in appearance, but brilliant in effect. In contrast, the BMW 801 demanded constant vigilance to prevent overheating. The R2800 could run at full power for hours without a single valve failing. As the night stretched on, the hangar became thick with the smell of hot oil and the sweat of men working too long. Henschel's hands were black with grease, yet his mind raced. Every component he removed told the same story: redundancy, resilience, and unwavering reliability. This engine was not built for aces or experimental prototypes. It was built for war. Real war, where machines endured mud, freezing cold, salt, and the mistakes of inexperienced pilots. The Americans had forged a weapon that could be flown by anyone, repaired almost anywhere, and mass-produced without compromise. When the magneto housing was finally opened, Henschel discovered yet another marvel. The ignition system was double redundant. 2 spark plugs per cylinder, 2 complete magnetos, twin distributors. If one system failed, the engine would continue to run. In the Luftwaffe, redundancy like this was seen as unnecessary weight. Here, it was standard. "They build like they don't care about limits," a mechanic muttered. "They don't have to," another replied. By 2 in the morning, the turbine wheel lay under the floodlight, its dimensions carefully measured. The chief engineer calculated the rotational speed over 20,000 revolutions per minute. His pencil faltered halfway down the page. "At these stresses, it should explode," he muttered. Henschel finished the thought. "Unless they know exactly how far they can push the metal." The words hovered in the air, half admiration, half despair. By dawn, the R2800 lay disassembled across 4 workbenches, its innards exposed like the anatomy of some extinct, formidable creature. The Germans gathered in silence. For years, they had believed in their own superiority, better pilots, superior tactics, advanced technology. But now, confronted with the engine's innermost secrets, they faced a harsher truth. The Americans had mastered something more powerful than clever invention. They had mastered scale. Every part of the R2800 whispered this fact. Behind each Thunderbolt was not a single genius, but an army of machines, workers, and factories. a vast industrial ecosystem built to outlast any enemy. Henschel lifted one piston, holding it to the light. The alloy was flawless, the surface polished like glass. He turned it over in his palm, feeling its weight. In another life, this could have been art. But it had been made for war, and somewhere, young American pilots trusted their lives to engines like this, knowing that thousands more waited back home to replace any lost. A luxury no German pilot could imagine. He set the piston down and whispered, "We can copy the shape, but not the soul." No one disagreed. Morning light spilled gray and cold through the hangar doors. The war still raged outside, but in that quiet, men stared at the tables, understanding a reality that the front lines had not yet grasped. The outcome of the conflict was already inscribed in metal. By sunrise, the R-2800 had been measured, studied, and analyzed. Yet the feeling it left was not triumph. It was awe, tinged with resignation. They had expected clever tricks, secret alloys, or hidden valve designs. What they found instead was something far more terrifying: the perfection of repetition. Every part, from the tiniest bolt to the largest turbine blade, bore serial codes tracing back to factories across the United States. Henschel held a connecting rod, stamped East Hartford, 1943, Lot 128. A signature and a taunt. Every marking told the same story. This was not the creation of a lone genius or workshop. It was the output of an industrial organism stretching from Detroit to Connecticut to Los Angeles. Later that week, a report arrived from Berlin, a grim ledger from the Luftwaffe's technical division. Henschel read silently. The United States was producing over 850 aircraft engines per week, each tested, crated, and shipped across the Atlantic. By winter 1944, more than 15,000 Thunderbolts had rolled off assembly lines, with Corsairs, Hellcats, and Marauders all using the same R-2800. Germany, by contrast, was struggling to produce 200 fighter engines a month, most assembled in bombed-out underground factories, where workers labored by candlelight. To an engineer, numbers tell their own story. And when Henschel compared these, he saw an unassailable truth. Even if Germany duplicated the R-2800 perfectly, they could never match the American speed or scale. Precision had been transformed into process. In Germany, it remained an art. One could be multiplied 1,000 times. The other could not. Inside the hangar, Henschel began dismantling the turbo housing for metallurgical analysis. The lab confirmed his fears. Turbine blades contained 22% nickel and 14% chromium metals Germany no longer possessed in sufficient quantities. By 1943, Reich stockpiles of nickel had fallen below half the amount needed for aircraft production. Chromium, mined mostly in the Balkans, was now under Allied control. Even with perfect blueprints, the raw materials were beyond reach. If we tried to cast this alloy with what we have, it would shatter before reaching operating temperature, a metallurgist said quietly. Henschel nodded. Then it isn't just the engine we cannot copy, he said, voice low. It's the civilization that built it. Across the Atlantic, that civilization was running at full throttle. In East Hartford, the Pratt and Whitney plant worked around the clock. 3 shifts of workers produced 2,000 engines a month, each identical. By night, the factory glowed like a furnace, powered by rivers and coal reserves untouched by bombs. Precision lathes shaped steel to tolerances measured in microns. Entire neighborhoods existed to house the workers who built engines like the one now laid bare in Rechlin. The Luftwaffe's intelligence found more contrasts. The average American engine mechanic had over 300 specialized tools. In Germany, shortages forced teams to share a single torque wrench. Americans used cobalt and molybdenum-rich alloys. Germans relied on recycled metals stripped from destroyed aircraft. The difference was not just quantitative, it was philosophical. German engineers believed perfection required human touch, that each machine bore the fingerprint of its maker. Americans believed perfection came from erasing those fingerprints. Reliability was not art, it was arithmetic. The irony was bitter, almost cruel. Henschel understood, with a clarity that chilled him, that a single R-2800 engine could endure what 3 BMW 801s could not. While Luftwaffe fighters groaned under the strain of 25 hours of flight before demanding major servicing, the Thunderbolt's heart could roar for more than 150 hours without pause. Imagine the skies over Europe. Every extra hour in the air was another chance to survive, another life spared. He turned back to the magneto housing, tracing its lines as if it might whisper its secrets. Redundancy, a concept the Germans had long scorned as unnecessary weight, was embedded everywhere. Every system contained backups, every connection doubled. The Americans had embraced inefficiency as insurance, abundance as strategy. That afternoon, Henschel drafted his report. Technical observations flowed in clinical language, excellent alloy composition, extraordinary thermal tolerance, reliability at high manifold pressure. But in the final paragraph, he allowed himself a moment of rare, candid reflection. This engine embodies a philosophy we cannot match. Its strength lies not in invention alone, but in the industrial depth of its nation. It is a weapon of production as much as of flight. When the report reached Berlin, it was compressed into 2 antiseptic sentences for the Air Ministry. The American R-2800 is unnecessarily heavy, but highly robust. Its power is derived from wasteful design and excessive material use. Bureaucrats underlined wasteful design as if it justified continued pursuit of lighter, more elegant engines. They did not see the truth. That very wastefulness was the secret of endurance and survival. Weeks later, a second R-2800 arrived from another crash site. By then, the engineers' enthusiasm had dulled. They already anticipated what awaited. Still, they repeated every measurement, every weighing, every analysis, and every time, the result was the same: precise, powerful, reliable, produced at a scale Germany could only dream of. Henschel began keeping his own private notes, scribbled in the margins of blueprints. Every component is built for forgiveness. They expect it to fail, and so they make sure it can. Those words captured the essence of 2 empires. Germany designed to avoid failure, America designed to survive it. As night fell, Henschel stood by the open hangar doors, snow drifting silently across the runway. The war was slipping away in ways no pilot could see, through shortages, exhaustion, and an enemy whose factories outproduced theirs 20-fold. The R-2800 was not a secret weapon. It was proof that technology had become subservient to economy, and economy had become destiny. In Berlin, the lesson was lost. By the time Henschel's report arrived, Luftwaffe leadership was trapped in another battle, fought not in the skies, but on paper. The Reich still possessed aircraft of extraordinary promise. The Me-262 jet, poised to revolutionize combat, the WWII-190D entering production, designers at Messerschmitt drafting concepts that seemed plucked from the future. Yet beneath the blueprints lurked a grim truth that no one wanted to voice. No fuel, no nickel, no time. In February 1944, General Feldmarschall Erhard Milch, head of aircraft development, reviewed the technical brief on the captured engine. His assistant summarized cautiously. Their design prioritizes reliability and mass manufacture, not elegance. Milch's eyes narrowed. So it's crude? Yes, sir, came the reply. But it works. Milch closed the folder with finality. We will not copy crude. That decision sealed dozens of choices that would haunt Germany's air war to the end. The R-2800's lesson was obvious, but the German system could not accept it. Technical superiority equaled victory. Invention was the path. Endurance was dismissed. Across the Atlantic, the American doctrine was reversed. Build simple, build strong, build so many that losing 100 meant nothing. That contrast now dictated the skies over Europe. By 1944, the Thunderbolt squadrons became a nightmare the Luftwaffe could not counter. Turbo-supercharged, capable of climbing above any piston plane Germany fielded, diving at 500 miles per hour, the P-47 escorted bombers deep into the Reich. Pilots dubbed it the Jug Short for Juggernaut, and the name was no exaggeration. German fighters intercepting B-17s found themselves hunted by these blunt-nosed monsters that refused to die. Each mission returned statistics that told the story in cold numbers. 7 times fewer engine failures than comparable German fighters. Even when damaged, many made it home. One pilot flew over 200 miles with a cracked piston still turning. The R-2800 didn't just provide power, it provided forgiveness. At Rechlin, Henschel's team received a directive: investigate turbocharger adaptation for German engines. It was a hopeless task. German factories lacked nickel for turbine blades and the machining capacity to craft delicate housings. Every attempt ended in disaster. BMW 801 prototypes melted or fractured. Materials simply could not endure what Americans treated as routine. Desperation bred obsession. Germany would build engines that burned bright and fast, if not long. The Me-262 jet became that obsession. Revolutionary, sleek, dangerously unreliable. The Jumbo 04 lasted a mere 25 hours per engine. Pilots approached takeoff as if gambling with fire. One throttle misstep, and the turbines would disintegrate. Yet Berlin demanded production. The logic was seductive. Perhaps one exceptional machine could outweigh hundreds of the enemy. But war does not reward perfection that cannot be replicated. Meanwhile, the Americans churned out their imperfect engines by the thousands. In Evansville, Indiana, a single factory produced more P-47s in 1944 than Germany manufactured all FW-190 variants combined. Each carried the same R-2800, identical reliability, identical survival margins. The Luftwaffe was bleeding in statistics it never saw. In July 1944, Henschel attended a technical conference in Augsburg. Senior engineers argued fiercely. Our designs are superior. Their strength is waste. Ours is genius. Henschel stood quietly, then said simply, "Genius requires fuel." Silence fell. The meaning was clear. German brilliance had reached its limits. It could neither power the machines it built, nor shield them from scarcity. By autumn, Allied bombers struck Luna and Merseburg daily. Without high-octane fuel, Luftwaffe engines faltered. Superchargers starved. Meanwhile, the R-2800 roared over Europe on a steady diet of Texas-refined 100-octane gasoline, escorted by convoys too numerous to halt. Every sortie, every mission, every escort was a lesson in a simple, unromantic truth. Logistics win wars. In one of his final reports, Henschel wrote a line later quoted by historians. "They built engines for soldiers. We built them for engineers." It was both confession and epitaph. The R-2800 did not defeat the Luftwaffe through genius. It defeated it through indifference to limitation. It asked no favors and yielded no fragility. Its secret lay in a nation that could break things faster than its enemies could replace them. When Berlin fell in May 1945, surviving technical staff at Rechlin burned their notes. Henschel did not. He packed sketches and alloy samples into a small case, believing that someday someone would need to learn what they had understood too late. Years later, Allied engineers found his notes among abandoned files. One margin caught their eye. "The engine is not what frightens me. What frightens me is how many of them they can build." That line captured everything Germany had failed to grasp. Power was no longer measured in horsepower or speed. It was the ability to reproduce excellence endlessly. If you think wars are won by invention, press 1 in the comments. If you believe they are won by endurance, hit like and subscribe, because in the next chapter, when the war ended, Otto Henschel would finally face the Americans and see the machine that had haunted him, not in ruins, but reborn in peace. When the war ended, silence settled over the hangars that had once roared with engines and rang with the clang of wrenches. Rechlin had become a graveyard. Test benches stood empty. Blueprints lay scattered across floors, coated in dust and oil. Otto Henschel lingered for weeks, long after most of his colleagues had fled west to avoid Soviet captivity. The war that had devoured his youth was over, and the machine that had defined his obsession, the American R-2800, had outlived the Reich that had tried to study it. Each morning, he walked the length of the hangar, stopping at the workbench where the engine had once lain open like a heart. "They built for tomorrow," he murmured to no one. By late 1945, the Allies had begun dismantling the remnants of Germany's aviation industry. American officers arrived at Rechlin with cameras, notebooks, and translators. They weren't hunting for secret weapons. They were searching for people who understood them. Henschel was one of the few engineers still present. When questioned about the R-2800, he told the truth. They had learned everything they could, and yet nothing they discovered could be used. An officer smiled. "Then you were studying a mirror," he said. Months later, under the program that would become Operation Paperclip, Henschel was invited to work in the United States. He hesitated. His family had survived the bombings of Hamburg, only to live now under occupation, and the thought of working for the victors felt like betrayal. Yet the pull of seeing the nation capable of building such machines drew him stronger than pride. In 1947, he arrived in Connecticut, not far from East Hartford, where the Pratt and Whitney plant still thundered day and night. The first time he walked through the factory, he stopped, astonished. It was louder than any foundry he had ever imagined. Rows of lathes, sparks from welding torches, cranes lifting polished crankcases the size of automobiles. Women in overalls checked tolerances with micrometers. Men in aprons fitted piston rings with surgeon-like precision. The air smelled of cutting oil and hot steel. He realized that the noise, the chaos, was not disorder. It was power made visible. When an American engineer noticed his accent and asked his thoughts on the plant, Henschel paused. "It's like watching mathematics being born," he said quietly. The man laughed. "No," he replied. "It's just Tuesday." Over the following years, Henschel worked on experimental jet projects, collaborating with engineers who had once tried to kill him and each other. Now, over coffee, they compared turbine designs, trading secrets like old soldiers trading scars. The lessons of the R-2800 lived on. Overbuilt bearings, redundant ignition systems, generous cooling margins. The philosophy of durability had become doctrine. Yet Henschel never stopped reflecting on that first night, in that dim hangar, opening the Thunderbolt's engine. In his notes, he wrote, "It wasn't their genius that defeated us. It was their patience. They built not for victory, but for continuity." When Pratt and Whitney engineers asked him to review the new J-57 jet engine, he recognized echoes of the double Wasp everywhere. The same devotion to temperature control, the same prioritization of reliability over elegance. He smiled and signed the report. History, it seemed, was repeating itself, only faster. In 1954, he attended an air show in New York. A restored P-47 Thunderbolt taxied onto the runway, its radial engine roaring with that deep, confident growl he remembered from Rechlin. As the aircraft climbed into the blue sky, trailing a halo of exhaust, the crowd cheered. No one knew that decades earlier, Henschel had taken that very engine apart, bolt by bolt, trying to understand how to defeat it. Watching it soar, he felt no bitterness, only a strange, profound gratitude. The sound was more than mechanical. It was historical, the echo of an era when strength meant survival. Years later, long after his retirement, Henschel wrote a letter to a former colleague who had stayed in Germany. "We learned too late. Perfection dies young. The machines that last are those built to forgive mistakes." The R-2800 had become more than an engine. It was a philosophy bridging war and peace, destruction and reconstruction. It taught that power was not the ability to create a perfect machine, but the ability to replicate it, time and time again. Every turbine that spun afterward, every jet that roared into the sky, carried a trace of that lesson, born in the fires of 1944. If you believe history is written by the victorious, press 1 in the comments. If you believe it is written by engineers, hit like and subscribe, because the story doesn't end with victory. It ends with understanding. History rarely remembers the men who turned wrenches. It celebrates pilots, generals, speeches shouted over radio static, but not the quiet figures who bent over engines in dim workshops, trying to make sense of metal. Yet it was in those workshops that the future was forged. Otto Henschel knew this truth better than most. In 1962, consulting on an aerospace project in Washington, D.C., he visited a museum. Beneath a polished glass dome stood a restored Pratt and Whitney R-2800 engine, silent and immaculate, preserved as if time itself had paused to honor it. He stepped closer, reading the small brass plate. Engine from a P-47 Thunderbolt, 1944. The same year he had first opened one in Rechlin. He ran his hand along the cool metal, feeling not regret, but recognition. A guide nearby explained to schoolchildren how this engine had powered fighters that won the air war over Europe. "It was strong enough to take bullets," she said proudly. "It never quit." Henschel smiled faintly. She was right, but not in the way she meant. Its true strength was not in horsepower or armor, but in the civilization that built it, a society that understood that durability is mercy, that forgiveness in metal can save lives. He looked around the hall at other relics, a sleek mosquito bomber, a squat Sherman tank, and the early jets that would soon conquer the skies. Different shapes, different nations, yet they shared a single secret. They were built by people who believed that simple designs, made in great numbers, could outlast brilliance made in isolation. That philosophy echoed through every rivet, every bearing. Outside, the world had changed. The Cold War had transformed engineering into a new kind of arms race. New aircraft flew higher, faster, deadlier, but more fragile, more dependent on perfection. Sometimes when a test engine failed, Henschel thought of the R-2800. It had never demanded perfection. It only demanded care. In his final notebook, he wrote, "Every machine is a reflection of its maker's soul. The Americans built for endurance and endured. Germany had built for glory, and glory burned out." That became his private epitaph. Henschel never sought credit for his wartime work. He considered it a lesson learned too late, too dearly. When he died in 1971, his papers were donated to a university archive. Among sketches and notes was a single black and white photograph from Rechlin, 1944. Mechanics gathered around a massive radial engine under a hanging lamp, young and serious, unaware they were staring at the future. On the back, in Henschel's hand, 4 words, "The day we understood." The echo of steel still speaks. It speaks through every jet that takes flight. every factory that hums at night, every engineer who chooses reliability over pride. Machines are mirrors, and progress, like mercy, comes not from brilliance, but from endurance. If you believe history is written in courage, press 1 in the comments. If you believe it is written in steel, hit like and subscribe. In every war, every invention, and every untold story, there is always another engine waiting to be heard.